everybody, welcome back to With the Motor 100. My name is Freek and today we're going to look at a battery that will not charge. So there's something wrong with the charging system. There's a little motorbike, a Kawa 305 here in the shop, and we're going to have a look at it. So first of all, I have a little diagram here showing the charging system, and we'll go over the components quickly. This is the alternator, three-phase alternator. You see the yellow phase leads going to the regulator rectifier, which is one unit in this case, and then we have the leads to the battery, the positive lead and the negative lead. That's the positive one, and that is the negative one. They both connect to a 6-pin connector, which connects to the regulator rectifier. Then there's one lead coming from the ignition switch and also going to the regulator rectifier. Now that lead is giving information about the voltage in the circuit, so the regulator can regulate. So it consists of 4 main components: the alternator, regulator, the battery, and then the wiring loom that connects it all. How does it look in practice? Here is the particular one for this bike. As you can see, it has cooling fins on it. Because in this case the surplus on electricity that's being formed by the alternator is getting transformed into heat, and so there's a heat sink and cooling fins with it. Then there's 2 bolts to attach it to the frame on a cool place, preferably, because it needs cooling. And then we have 6 pins to connect it all to the system. And as we have seen before, there are 3 leads going to the alternator, and then there is our positive and negative lead that go to the battery, and then we have the 1 lead leading to the ignition switch. So there you have it. That's how it looks on this bike. If it doesn't work, if it's broken, then you can't really repair it. You just have to replace it. So, quick recap. First we test the alternator. Is it alright? Okay. Then we test the wiring loom. Alright. Okay. Then the regulator is at fault. So here we are at the bike. And with our testing device already in place, there is the connector, and so these are the 3 yellow AC leads. We're going to start at the bike, turn on the meter, put it on AC. Of course, we will be measuring AC if we're lucky, and then just fire at the bike. Here we are. So this bike has not been properly tuned yet, so it's a bit of a fiddle to keep it running, but we'll manage. Okay, now when it's running fairly steadily, we'll just start these tests, and yeah, there we go. Finding the yellow leads, and then see if we have AC voltage. Normally at 4,000 RPM you can measure 70 volts. We will go up to 3,000, and in this case we got to about 60 volts. at 3000 RPM. At very low revs we were already over 30 volts, close to 40 volts, so it all looked really nice. I always do these measurements twice, just to be sure, and sometimes you find little inconsistencies that have to do with the connector not being clean, so resistances will sometimes put you off a little, and it's of course a fair warning. You really want to have these cleaned before you put it all back together. You don't want resistances in the circuit. It's one of the many things that destroys regulators. Sometimes you see them badly corroded, and that gives so much resistance that it heats up real bad, and you can even sometimes find that the connectors are molten. You know, the plastic is molten, so yeah, that's not what you want. All right. We're done testing here. Alternator's all right, so we're on to the next one. So next is the other leads, which means the one that goes to the battery negative, the one that goes to the battery positive, and the one that goes to the ignition switch. These three we've tested now. Okay, here we are. So what I'm going to test here first is the one going to the battery negative. The battery's negative is connected to the frame, so if I would measure between battery negative here on this lead and the frame, it should read next to zero resistance, just a couple of tenths of ohms. .5 ohms, slightly more than you would expect, so there you go, a little wiggle on the test lead, and there you go, 0.2, 0.3, which is good. This is ohms reading, of course. Now we switch to voltage DC, and we go to the positive lead, the constant positive lead, and it reads battery voltage, which is good. And then we go to a wire going to the ignition switch with the switch off. It reads a couple of millivolts. Now the switch is on, and we should read battery voltage again, which we do. Right, so that completes this test. And it tells us that the wiring loom is in order, so that is not the reason that this battery wouldn't charge. Also, the alternator was not the reason, so the regulator is at fault. Now, as I said earlier, you cannot repair this regulator. We have established that it is faulty, so we need to order another one. I'll get one from a breaker's yard, and we'll get it here, and we'll get it on the bike. So here we are, back again. We have our regulator rectifier, and we're ready to put it back in the bike, and then just test it out, see if we have fixed the problem. Then back at the bike. As you can see, here's the regulator connected to the wiring loom. So all we have to do now is to start up the bike. What you can see right now on the voltmeter is the is battery voltage. try and zoom in. Now that's it. With the ignition switch on, ignition switch off, there you go, 13 volts. Okay, now we switch it on, then switch the lights on, and you can see that the voltage will drop a little more. Here we go. Then we'll go start the engine, which makes the voltage drop a little more severe, but then when the engine's running it should come right up to a little over 14 volts, if it's all in order now. So here we go. Wait for it. Takes a little longer in Dutch to explain it all. And here you have it. Engine running and it's charging. So always double check, at least I always do. So I stick on the old one, the old regulator, and then start the engine again. See what we have. Stick on the old one. Here we are. Ignition on, lights on, start. Engine running, and voltage is not rising. Switch again. There we go. Start engine. Boom. Right back on 14 volts. So we're more than happy than this. This repair is a success. So here we are. We managed to identify and solve the problem. Thanks for watching. Please like, subscribe. Looking forward to your comments, and hope you have a nice day. See you all.